Fibers are the key building blocks of all textile and apparel products. Fiber characteristics have a huge impact on yarn performance and, of course, fabric and garment performance. With regard to size, the key characteristics of a textile fiber is a high length to diameter ratio of at least 1,000 to 1. In addition, the diameter or fineness of the fiber should not be greater than 20 microns, or an equivalent of 0.01 inches. It's preferred that a textile fiber be clear or white in color in its manufactured state, so that a full palette of colors can be achieved during mill processing. With regard to performance in use and laundering, a textile fiber should have sufficient strength and extensibility. Also, a wide range of temperature resistance is required to allow for mill processing techniques and to allow for consumer laundering. Special end-use requirements such as flame resistance, melting resistance, high tensile strength, and protection in extreme climatic conditions will determine the type and amount of fiber used. Chemical resistance is also key for mill processing and product care. Fibers such as polyester and cotton perform very well over a wide range of chemical processes. Cotton fibers, as well as other natural fibers such as wool and silk, have a wide range of properties and excel in the attributes of softness, moisture management, and other comfort aspects. Cotton fiber tends to do very well in laundering due to its increase in strength when wet. Cotton fiber properties are measured in the United States using a single process called a high-volume instrument tester. This high-speed system provides data on fiber length uniformity, strength, elongation, micronaire, maturity, leaf, and trash content. Other attributes of cotton fiber can also be accurately measured if needed. ASTM and AATCC have specific test methods for the assessment of fiber characteristics and performance. With regard to apparel and home products, the determination of fiber content is required for point of sale and care of the product. There are federal laws, such as the Textile Fiber Products Identification Act and the Wool Products Labeling Act. Specifically, care labeling as to fiber content is important for handling during laundering and other related aspects. Certainly, accurate fiber content description is related to the cost or assumed cost of a product. Trade names for fibers can often make a difference to consumers when used in marketing labels. Lycra might be listed as the trade name for the type of spandex used in a particular product. Also, different types of the same fiber like Pima, Peruvian, and Egyptian are recognized as special quality cotton fibers. However, labeling refers to the generic name of the fiber. Two of the fiber attributes that must be made available to the consumer through the care label are the generic fibers in the products and the percentage of each. Qualitative procedures have been developed to identify the generic fibers in the product. Test methods AATCC and ASTM are documents for identification. AATCC Test Method 20, Fiber Analysis Qualitative, and ASTM Test Method D276, Identification of Fibers in Textiles, offer several procedures for an assessment of the fiber type used in the product. Microscopy can be used to identify fibers by their cross-sectional and longitudinal shapes. Cotton, for example, has a kidney or kidney bean shape. Its longitudinal configuration is one of convolutions or twists. Typically, a yarn will be removed from the fabric and analyzed. The entire bundle may be examined as a cross-sectional dissection and the fibers therein identified. For the longitudinal direction, individual fibers are removed and examined under the microscope. AATCC Test Method 20 gives detailed cross-sectional and longitudinal views of the major fibers, both man-made and natural, for easy identification. Shown here is the cross-sectional view of a cotton fiber. Notice the kidney shape. Also shown is the longitudinal view, which reveals the convolutions of the fiber. Both of these characteristics are indicative of cotton. Next, we see cross-sectional and longitudinal views of wool fiber and bright nylon fibers. There are similarities between the cross-sectional views. However, examining the longitudinal views, the wool fibers have obvious scales, while the nylon fiber is very smooth. One technique in Test Method 20 that provides a simple and quick test is the burning of the fibers. This test has a chart that describes the reaction of the fiber to a flame. The reactions relate to whether the fiber melts when near the flame, shrinks away from the flame, or does not react to the flame. Also, when the flame is applied directly to the fiber, whether or not it burns, and if it continues to burn, are observed. If it self-extinguishes or does not burn at all, this is recorded. Finally, guidelines for the analysis of the ash are provided. For example, if the fiber burns and a hard, round, and black residue forms, then the fiber is probably polyester or nylon. Within the test method, the fibers can be analyzed with regard to the physical properties of density, melting point, refractive indices, and by refringence. When an unknown fiber is analyzed for all these parameters, identification may be possible as a result of the process of elimination. For example, some variants of bright nylon, polyester, and polyethylene can be quite similar in cross-sectional appearance, but quite different in their densities, melting points, and other values outlined in the physical properties. Chemical solubility is an important analysis tool for fiber identification. Most often, one fiber will dissolve in a different chemical than another fiber. For example, cotton will dissolve in a strong solution of sulfuric acid, while polyester will not. However, cotton and rayon both will dissolve in a strong solution of sulfuric acid. A complete chemical analysis procedure is given in AATCC Test Method 20A. If an analysis of the blend level of a product is desired, the test method gives a sequential procedure for determining the fibers in the blend. This systematic analysis will determine the constituents of a blend by the process of elimination. This analysis can be combined with microscopy and the other test protocols for a final determination. Another method used today for fiber identification is spectroscopy. A spectrophotometer distinguishes one fiber from another by the different wavelength of light energy that's absorbed or transmitted through the fiber. Each fiber has its own distinguishable graph of peaks and valleys over the wavelengths to which it's exposed. The Micro-Fourier Transform Infrared System, FTIR, is commonly used to identify many materials, one of which is fiber. Most of the other tests discussed are related to the chemical nature of the fiber and not the physical shape. Cross-sections may vary due to modifications of a generic type of fiber by different manufacturers and for different end uses. FTIR techniques can be used to not only identify the fibers, but can be useful in determining blend level. The test method gives identification curves for some fibers. Laboratories involved in this type of analysis generate their own libraries of curves for fibers they encounter in testing.